Our project is a DES encryption algorithm for a pipeline processor. For the DES algorithm to properly run, we need to give it two things: data to be encrypted and a key. Both must be 64-bit numbers. And it outputs one 64-bit number we call the ciphertext. Of the 64 bits in the key, only 56 are used. Every 8th bit is discarded. From the 64-bit number key, we will create 16 subkeys, each of which are 48 bits long. First, to create the subkeys, we must start with an initial permutation on the key. We then divide the key into two parts, a right and a left part. We then run the key through 16 rounds. Each round's key is formed from the previous one by left rotate. According to a given table, we decide whether to left rotate once or twice. For example, the first block is rotated once, while the third is rotated twice. Then the two parts are concatenated into one, and a second permutation, according to another table, is the key is put through. This permutation is done 16 times, and each subkey is on each subkey in order to produce the final 16 keys. Then we move on to encrypting the data. First, an initial permutation is done on the data. Then the 64-bit data is divided into two 32-bit numbers we call the left and right parts. The right 32 bits is put through an expand permutation to match the size of the 48-bit key. This permutation is done by copying certain bits. Then for each side, we put them through a function. So the left side just gets the right side in the previous round, whereas the right side gets the left side XORed with a function of the right side and the key for that round. The 48 bits are then divided into 8 groups, each group containing 6 bits. Each 6-bit group is then passed into an S box. There are 8 S boxes in total. Each S box is a lookup table that outputs 4 bits. We then combine the output of the S boxes into one 32-bit number, and this number is going to be going through a final permutation for each round, and there are 16 rounds in total. Finally, after all 16 rounds, an inverse permutation is done to generate the final ciphertext.
Now we would like to show you how it works in the D2 board. So we pull out the DES calculator, and what we put for the key, we put just all ones, and for the data we put all zeros, just to make it simple. So here I'm going to put in the data. So as you can see, all the key, I'm so sorry, yeah. We put here all the switches set to ones. The last two switches gonna distinguish between 0, 1, 2, and 3, because each one of them gonna give us 16-bit. 4 times will be 64-bit key. So I'm gonna start. Right now I'm gonna place the first 16-bit. Here I'm pressing for the key, and then I'm placing the second 16-bit. Again, all ones. The third 16-bit. And then the fourth one, I'm placing it here. Now we made it really simple, because right now we don't need to put the data, because it's all zeros and automatically it's in. Now if we can look at here, for the ciphertext, you will see the output. So I'm going to start from the highest best. It's CAAA. If I'm going here, you see it shows CAAA. Then I'm going back, it's AF4D. So I'm going here and I'm placing AF4D. Then we're going here, EAF1, going back, switching this one, EAF1, and the last 4 are DBAE. We're going back, I'm switching it to the last one, DBAE, and this is our ciphertext. Thank you.